Good afternoon and welcome to today's presentation, Litigation of Building Defects, Earning, Cost, Health, Safety, and Comfort, Part 2. In today's webinar, Donald Wulfinghoff will discuss who's at fault, litigation challenges, how to select your expert or experts, conclusions and recommendations. To give you a little background about our presenter, Donald Wulfinghoff is a professional engineer. He has been a licensed building engineer, a commercial broadcast engineer, and a certified automotive mechanic. Don has investigated and testified in cases related to shipbuilding, automotive accidents, and energy systems. He has been improving the quality of buildings since 1974 and is the author of 2 revolutionary books on building design and operation. Congressman Roscoe Bartlett, the renowned sustainability sage, described him as the world's leading expert on energy efficiency in buildings. Attendees who require a passcode, the word for today is defect. During the Q&A session, we ask that you enter this passcode into the Q&A widget for CLE reporting purposes. The Q&A is located to the left of your screen. Please remember that if you are applying for CLE credit, you must log on to your computer as yourself and stay for the full 60 minutes. You are also required to complete the survey at the end of the program. Please note that CLE credit cannot be given to those watching together on a single computer. Tomorrow morning, we will send out an email with a link to the archived recording of the webinar. The slides can be downloaded from the resource list to the left of your screen. Thank you all for attending today, and Donald, the presentation is now turned over to you.
Hello, once again, I am Don Wulfinghoff, and it's a pleasure to be back with you. To review, this 2-part webinar focuses on defects in the design, construction, and operation of buildings that commonly cause serious damages to building owners, occupants, and others. We cover these types of defects together, including health, safety, and comfort problems, because they typically have common origins in the energy design and the energy systems of buildings. The resulting damages often are the result of incompetence, willful negligence, and reckless disregard of the welfare of the client and of society. This area of litigation is relatively new, and it is largely unsettled. Damages often are unrecognized, and they are generally under-litigated. As a result, the chances of recovery and the size of the award will depend on better understanding by attorneys of this area of damages. This is a big topic in both subject matter and damages, so we're presenting it in 2 parts. Previously, on Tuesday, we discussed the magnitude of the potential damages amounting to hundreds of billions of dollars per year. We described the types of damages, and we summarized who is harmed. That is, who are the potential plaintiffs. The first part has been recorded, and it is available now on the TASA website. Today, we will consider who's at fault. That is, who are the potential defendants. We'll consider the unusual litigation aspects of this area of damages and how to find the experts you'll need to make your case effectively. Finally, we'll wrap up with conclusions and recommendations. Now we move on to the next key litigation question, which is, who's at fault? In other words, who are the potential defendants? This is likely to become an exercise in mutual finger-pointing among the several parties who may be responsible for damages or those who may be falsely accused. These are the potentially responsible parties: the owner, the designers, the builders, equipment manufacturers, equipment vendors, energy suppliers, commissioning agents, facility operators, and the tenants and occupants of the building. Well, let me recommend that you use this slide as a checklist when you are considering who is responsible. Before we discuss who may be potentially responsible for damages, there's an important caution to observe. Be sure that you assess fault correctly before joining other parties in litigation or filing against any party, and involve your experts in this assessment. For example, I was called to troubleshoot some serious comfort problems in a newly built office building. While I was doing that, I was informed that a suit had been filed jointly by the owner and the architect against the contractor. Apparently, the architect told the owner that the problems were the contractor's fault. However, in the course of inspecting the building, I found out that the problems in the building were largely the fault of the architectural design, whereas the contractor had simply built the building in the way that the architect designed it. As a result, the owner's case was severely weakened. Haste makes waste. Be sure you know who really is at fault before filing suit. It's not necessary to be a construction specialist or a construction attorney to litigate building defects that we've been discussing, but it is necessary to understand the parties involved. To do so, let's summarize the process by which a building comes into existence. First of all, the owner hires a principal designer. That may be an architect or it may not be, doesn't have to be. The principal designer hires consultant designers. The designers make drawings and they write specifications within their respective specialties. In a large project especially, the owner may hire a construction manager. The owner, to get the building built, hires a general contractor, and the general contractor hires subcontractors. Some of these contractors produce what are called shop drawings. Shop drawings are more detailed drawings than the drawings that are made by the designers, and they are details within the areas of expertise of the individual contractors. Then the designers review the shop drawings and must approve them. Materials and equipment are purchased, and those purchases are governed by the design specifications that the designers had previously written. Then the contractors proceed to build the facility. Throughout construction, changes may be made. They may be initiated by the owner, by the designers, by the contractor, and sometimes by other parties. All such changes must be approved by the designers. Then as we near completion of the building, the designers may check the proper operation of the facility, or they may not. That's a service that carries an extra fee, and the owner may or may not want to pay it. Or the owner may hire a commissioning agent to check the proper operation of the facility, or the owner may hire no one to check the proper operation of the facility, which is usually a big mistake. Then the facility staff moves in and operates the building, and tenants and visitors occupy the building. So now that we understand how buildings are created, let's examine the various types of people who create them. First, let's focus on the designers. A large fraction of defects are originated by one or more of the designers. That's because it's the designers who tell the other parties how to build the building, or who fail to do so adequately. By law, any commercial building must have a number of designers, each responsible for different aspects of the design. Building designers include the architect, who does space layout, decoration, and some other functions, the HVAC engineer, and HVAC stands for heating, ventilating, and air conditioning. And in the building trade, the HVAC engineer is commonly called the mechanical engineer, who designs the systems that make the building habitable. The plumbing engineer designs the water, sewer, and fire protection systems. The electrical engineer designs the electrical power distribution. Structural engineer designs the structure that holds the building up. And the lighting designer designs the lighting. Now, the lighting designer may be the architect, may be the electrical engineer, or may be a specialist who calls himself a lighting designer. Then there will be special function designers for a lot of buildings. For example, if the building has a cafeteria, a food service designer will be hired to design the kitchen equipment. If it's a medical facility, there will be one or more medical systems specialists who will design those systems, and so forth. Let me recommend that you use this slide as a checklist when you have a case involving possible culpability by the building designers. Where do you go to identify the designers? Well, you can start by looking at the cover sheet of the drawings. Here's a typical example. The drawings are legal documents. They carry the seals of the licensed professionals, and they identify all the parties who make drawings or write specifications. Not all designers are equal. Some must be licensed to accomplish their specific areas of design, while others are not required to be licensed. For example, lighting designers are not legally licensed in most jurisdictions. Most commercial buildings have at least 4 licensed designers: the architect, the structural engineer, the electrical engineer, and the mechanical engineer. A licensed plumbing engineer is a subspecialty of mechanical engineering, and a licensed civil engineer may be involved in site preparation. In principle, each licensed designer has sole authority within his area of design. For example, the architect cannot dictate the type of HVAC system, so the HVAC engineer could and should negotiate a change to any aspect of the architectural design that would prevent proper operation of the HVAC. In practice, this often does not occur. A design professional may fail to exercise sufficient authority within his own specialty. This is a prevalent problem with the mechanical engineer, who may produce an inferior HVAC design to accommodate the architect who hires him. What are the most common causes of building design defects? Deficient competence of the architect, deficient competence of the mechanical engineer, and at this point I'll say that it is usually one or both of these two designers who are responsible for the types of damages that we're covering. Sometimes the plumbing engineer or the lighting designer may also be responsible. Almost never the electrical engineer, the structural engineer, the civil engineer, the landscape architect, or others. Disregard of comfort and health as a design issue is endemic among architects in particular, and ironically, sometimes insufficient regard to comfort and health occurs among the mechanical engineers who actually initiated progress in that area. Disregard of operability as a design issue is a fault usually of the mechanical engineer. Operability means the ability of the facility staff and the occupants to actually make the systems in the building work. Disregard of codes and standards is endemic among architects and to a lesser extent among the mechanical engineers. Inadequate coordination among designers is a persistent complaint, especially of the engineers, and rivalry exists, especially between the architect and the mechanical engineer. That's because the HVAC systems have space and aesthetic requirements that impinge on the architectural layout of the building. And also, perhaps more fundamentally, because mechanical engineers have led the development of efficiency, comfort, and health standards since the 1970s. The emphasis on those important issues has elevated the status of the mechanical engineer relative to that of the architect, which challenges the primacy of architects as the primary income earners in the design business. This issue leads us to consider the relationships among the designers. Building design involves a hierarchy, so culpability may extend from the originator of the damages to those higher in the design organization. For example, if the mechanical engineer creates a defect in the building, responsibility for that defect may be inherited by the architect if the architect is in charge of the design organization. The captain of the ship is answerable for all mishaps. Now, usually it's an architect who sits at the top of the design organization, and that's primarily because he sells the project to the owner and collects the design fee. The lead role of the architect, when that occurs, is no longer due to broad design competence by the architect. That has faded away among architects since the late 1800s, when the new technologies of electric lighting, steam heating, and cooling established engineering specialties that took over the technical aspects of design, while architects narrowed their scope to space planning, decoration, and as much as possible to the overall administration of the project. Today, the architect makes a living largely as a broker of the design services of the engineers and the other specialists. So, to the architect who collects the design fee from the owner, the fees of the other designers are costs to be minimized. As a result, the competence of the other designers may be severely inadequate. The architect may hire the cheapest engineers he can find rather than selecting the best engineers. And in fact, this has led to a generalized stifling of competence among engineers, especially the HVAC engineers. Regretfully, I have seen the HVAC systems of buildings being designed by engineers who could not perform the elementary calculations of the profession. So based on that discussion, here are some questions to consider in determining design fault. Who headed the design team? Who collected the design fees from the owner? What was the chain of design responsibility? Was each designer in the team adequately competent? Did the designers warn the owner of increased energy costs and habitability problems resulting from the designer's preferences? For example, if the architect designed a building with a lot of exterior glass because that's currently fashionable, did he warn the owner that this feature will result in increased energy costs, probable discomfort, and visual glare, and possibly conflict with the adjacent buildings? And finally, were the designers responsible for the quality of construction? And I have to say, the duty of designers to supervise construction is still an unsettled issue in law with conflicting decisions. You would think after all this time that that would be a settled issue, but it's not. And this will be a major litigation issue if both the designers and the contractors are involved in buildings defects. Now we'll move on to the next group of responsible parties, the builders, by which we mean the general contractor, the subcontractors, and the construction manager if there is one. What's a construction manager? Basically, he's a scheduler, coordinator, and accountant. Those functions commonly are performed by the general contractor, except in very large projects where a separate construction manager will be hired. How do the builders contribute to building defects? Deficient competence is a common problem. A certain fraction of construction personnel lack the competence for their work. Inadequate supervision is another common problem. The foreman at the construction site is like the conductor of an orchestra. I have seen a construction crew start to make serious mistakes as soon as the foreman went to lunch. So a legal question for the attorney is to ask whether a competent foreman was on the job at all times. Substitution of inferior equipment is a continuing problem because the contractor buys the equipment and he wants to pocket the difference in cost between the specified equipment and cheaper equipment. Ignoring installation instructions is almost default behavior among some of the building trades. I have seen heat pumps, flow metering equipment, and lots of other equipment installed incorrectly because definitive detailed instructions that were provided by the manufacturer were simply ignored. And flawed construction methods occur especially when the designers fail to adequately describe the correct methods. For example, I have seen insulation bats for a wall suspended with nothing but tape. Of course, the tape came loose quickly and the insulation fell to a pile at the bottom of the wall. In this case, the architectural drawings did not provide any detail on how the insulation was to be held in place. However, the insulation contractor should have known that tape wouldn't work, and he should have asked for guidance from the architect, or he should have worked out an effective installation method himself and submitted shop drawings for approval from the designers. Lack of coordination among the trades is a classic problem. For example, sewer drains and ventilation ducts may collide because the plumbing and HVAC designers didn't coordinate their drawings. The equipment itself may have defects out of the box. Equipment will cause trouble if it is inappropriate for the application. Now, fault in this case goes back to the designers who specified the equipment negligently, or to contractors who substituted cheaper equipment for properly specified equipment. Defects in the manufacturer's design of equipment are becoming more common. For example, a common defect in cooling equipment is coil fin spacing that's too narrow. So that keeps the coils wet and causes humidity and mildew problems. This is done to minimize equipment size, probably to lower production cost, and sometimes to increase efficiency ratings. The rapid evolution of electronic controls is expanding the functions that may be performed by equipment, but often the controls are so difficult to use that performance is actually degraded. So here's a related legal question. Is the equipment manufacturer, vendor, or specifier liable for equipment that becomes obsolete and unrepairable after a brief period of time, rendering it useless? Are equipment vendors liable for defects in the equipment they sell? In building design, the situation may or may not be analogous to pharmaceutical reps who educate physicians about drugs. The licensed professional, whether he's a physician or a building designer, is supposed to be completely skeptical of the claims of vendors and to form an independent judgment. But it's my impression that designers commonly fail to adequately research the equipment they specify. They specify equipment on faith based on the claims of vendors and fail to inquire into the disadvantages or weaknesses of the equipment. And all equipment has advantages and disadvantages. That is the fault of the professional. But does the vendor have a duty to detail the shortcomings of their products? We may believe that a pharmaceutical rep has the responsibility, but does the vendor of equipment that is installed in buildings? Now we come to commissioning, which is a new term for the age-old practice of checking the operation of a newly constructed building. The concept of commissioning as a new term arose in response to the fact that contemporary buildings are often found to have a large number of flaws at the time the building is supposed to be completed. Commissioning agents are relatively new participants in construction. The commissioning agent is an independently hired party who supposedly can find the flaws in the building and fix them. I think that is probably an unrealistic expectation for a variety of reasons. However, a commissioning agent may provide a fresh set of eyes. A commissioning agent should prepare a report stating the conditions that he finds in proposed correction defects. But regardless of whether a designated commissioning agent is involved, there usually are so-called punch lists of corrective actions needed for defects that are found during construction. So if there is litigation, it's important for the attorney to get commissioning reports and defect lists during discovery. The next group of responsible parties are the facility operators. A commercial building is like a ship. It needs a crew in order to function. Some building operators who have critical responsibilities require licenses. In a large building, there may be a dozen or more licensed building engineers and perhaps many more unlicensed staff. This here happens to be my own building engineer's license, which I got by taking an examination around the mid-1970s. I never actually worked as a building operator, but I recognized that their role was so important that I decided to qualify as a way of understanding what they do. So, how are facility operators involved with building defects and damages? Well, operators may waste energy, they may cause or exacerbate comfort, health, and safety problems, and for sure, unqualified and improperly managed operating staff will cause problems. Deficient design may, however, make it difficult or impossible for even the best facility staff to operate the facility properly. Operating the building has become more problematic as equipment becomes more capable, but also more complex. And increasingly, I observe that control systems for the HVAC and lighting have become incomprehensible to the facility staff and to the occupants of the building. This problem stems, I believe, largely from the fact that younger contemporary designers are out of touch with the realities of actual facility design. For example, I was recently asked to lecture to a group of graduate students of mechanical engineering at a university in Washington, D.C. Now, these were graduate students. They already had degrees in mechanical engineering, BSME. So supposedly they were ready to do useful work. But I asked them who was responsible for maintaining the school's buildings. And their answers indicated that they were completely unaware of the existence of the campus operating staff. Now, if those students had not been in graduate school, they would have been working as designers in engineering firms, oblivious to the operating conditions inside the building. And years ago, I heard an engineer say that it was his job to design the systems, but it was not his responsibility if the staff did not operate the systems the way he designed them. I disagree with that. It's my opinion that a building is improperly designed if it can't be operated reliably by a staff having average competence. After all, an automobile manufacturer would not sell cars that can't be driven safely by average people. What is the liability of the tenants and occupants of a building? Yet again, the building's design and construction are prime factors in any damages that may be caused by tenants and occupants. Here's a fundamental fact. Tenants generally will do whatever is necessary to make themselves comfortable. For example, look at any glass box office building from the outside, especially on the south and west faces. You just stand on the street, walk down the sidewalk, and look at all the glass box buildings. Usually, you won't be able to look into the building because the glass has been completely covered to block the glare from sunlight. I have even seen newspapers being taped over the glass by occupants to make themselves avoid the misery of the bright sunlight. The HVAC design often causes discomfort by failing to provide separate heating and cooling for spaces that have different requirements. For example, restaurant design often fails to provide separate cooling for the kitchen and the dining area. The cooks will lower the thermostat setting to make themselves comfortable in the kitchen and thereby make the customers in the dining area uncomfortably cold. So the customers don't return to that restaurant and the owner loses revenue and can't figure out why. HVAC contractors make mistakes that cause occupants to waste energy. For example, I have repeatedly seen thermostats installed in the wrong places. If you look in the energy efficiency manual, there's a picture that I took of thermostats for 3 different rooms in a police station, all clustered together in one place, where they were exposed to direct sunlight. The heating by sunlight caused the thermostats to warm up and think that the space was too hot and turn off the heating to all rooms. So the cops responded by turning the thermostats all the way up so that the heating would go on and controlling the room temperature by opening the windows, which of course is very wasteful. So the moral is a building should be designed and built so that tenants and occupants have little motivation and only minimum ability to waste energy or to create comfort, health, and safety problems. So if you have a complaint about occupant behavior, look at the designers and look at the contractors. Finally, what is the liability of energy suppliers? In the first session, we talked about the extra cost that occurs if a facility purchases electricity or gas under a rate schedule that is not the most advantageous for the facility. Also, we discussed the large stranded cost that a facility faces if a utility incentive program is discontinued and the facility has bought a lot of expensive equipment to earn that utility incentive. So here are some questions for the attorney to consider when deciding whether there is a cause of action against the energy supplier. Who's at fault if the facility purchases energy under a disadvantageous rate schedule? Who's at fault if an energy supplier discontinues an incentive program that incurred major costs to the facility? The answers may be determined more or less easily by reading the contract between the energy supplier and the customer. However, I've found that the contract usually is silent on these issues, and in that case, the plaintiff must make an effective argument for redress. And that concludes our discussion of the potential defendants in litigation. Shall we take a brief pause for questions?
Thanks, Don. If everyone could type in the passcode in the Q&A, that'd be great. Our first question is from Sydney. I've noticed many suits over poor materials such as siding, Trex decks, poorly mixed cement. Shouldn't they be included in the category of builders?
Oh, yes, I believe so, yeah. Now, the liability there, I would say, is both, well, it cuts 3 ways. First of all, designers. If the building had a designer, the designer should have investigated the properties of those materials. And especially if it was a large commercial building, he should have written specifications or the proper formulation of the concrete. Then, in addition to that, the vendor, well, you can't blame the vendor in that case too much, I think. Then you have to blame the manufacturer of the equipment if the equipment was defective, and you have to blame the contractor for selecting that equipment. So you have divided liability there.
Okay. How do you determine whether a complaint by a building owner or occupant is valid?
Well, you first look at what the owner or the occupant is claiming. And you may have to go to the site and see whether the condition, which might be discomfort or a health hazard or whatever, actually exists. So first you listen to the client, and then you go and do an actual investigation. That means the attorney sending his expert to the site and preferably going to the site with the expert.
Since certain major damages are prevalent, is there the possibility of class action suits against the responsible parties?
You know, that is a very intriguing question, and one that I have been thinking about for some time. Now, I'm not an attorney, so I don't know the law of class action suits very well, but as I understand it, it results when you have a more or less common defect that is occurring widely among a lot of individuals as a result of one or more causative agents in a group, which could be a manufacturer or what have you. So you think about tobacco, asbestos, medical implants, and so forth, class action suits in those cases. And I think as I'm walking down the street looking at glass box buildings, I'm thinking, should this be a class action suit? Because all of these buildings are sitting here. They've all been designed by the same group of designers, and they're all causing harm in the same way. So I don't know, but I think it's a question that deserves considerable attention from attorneys.
Is there a legal requirement for an architect to head the design team?
No, not as far as I know. Now, that may vary from jurisdiction to jurisdiction. The architect normally heads the design team because he's a better salesman than the engineers are. He's good at talking to the owners of the building about how great it's going to look, and makes a nice model and makes nice drawings, and that's what sells the deal. So he gets to be the guy in charge because he gets the fee, and then he dribbles the fee out to the other designers. But I don't believe that there is a requirement. And in fact, I know of one engineer I've known a long time, and he does the lead design. Not he says, I can hire architects, but when the building is being built, he's the lead designer.
Okay, thanks, Don. If you can continue on, that'd be great.
Okay, we'll do that.
Thank you.
And the next topic is litigation challenges. Litigation of the areas that we have been discussing is still in a nascent state. As far as I know, few cases have gone to trial, and we lack information about cases that were settled. So this creates challenges for the attorney, but for the creative attorney, it also opens opportunities for making the case because there are fewer constraints that are imposed by precedent. Damages related to buildings have been occurring for a long time, for perhaps thousands of years. So perhaps we should begin by asking, why is litigation of buildings defects not more common? And by the same token, why has litigation not yet been able to perform the important social function of litigation by correcting widespread abuse? I believe that the reason primarily is that the types of damages we are discussing, especially excessive energy costs, are still being treated as a fact of life, as black lung disease was once treated as a fact of life in coal mining, until somebody discovered it didn't have to be that way. Also, damages caused by building defects commonly occur for reasons that are incomprehensible to the building owner. Unlike the relationship, say, between a patient and his physician, the building owner does not have an easily accessible, credible authority to explain why his building has its problems. Also, the perpetrator of the defects, who may be the architect or one of the engineers or the contractor, may deliberately misdirect the victim. I've seen that happen. The perpetrator may say, "Oh, that's normal," or "That's the state of the art," or "I can help you solve that problem for an additional fee," or "We'll fix that problem after the building is built," or "It's the fault of somebody else." Also, the victim doesn't know how to achieve redress. And I believe that is largely because attorneys have not yet learned how to connect with victims of building defects as effective as attorneys connect with victims of automobile accidents, medical malpractice, and so forth. We discussed this in the first session, and it's ironic because building owners tend to cluster in a few groups where they're actively exchanging information, and an attorney could educate that group of people very easily. So it's not necessary for attorneys involved with building defects to advertise on billboards along the highway or to plaster stickers on phone books. Another challenge of this area of litigation is that the attorney is undertaking a certain amount of legal pioneering. This is because, as we said, there is limited guidance from precedent cases. And another area where I think some legal pioneering is going to be needed is in the area of standard of care. Now, I'm stepping into legal territory, which is not my area of expertise, but from reading innumerable Schinnerer briefs, it appears that the principle of standard of care in engineering is that a practitioner fulfills his duty if his work is comparable to the average of the work performed by other engineers. So, for example, most bridges don't fall down. So a bridge designer is expected to design his bridges so they don't fall down. But we have a problem in the area that we're dealing with. Is a standard of care reasonable if the prevailing practice is deficient? For example, and in particular, if the energy costs of most buildings are higher than they reasonably should be, is the architect or engineer who designs a wasteful building liable for the excess energy costs of the building? Can he claim that because all buildings are wasteful, therefore they're off the hook? As far as I can tell, this question has not been adequately addressed, much less resolved. So, if the criterion of standard of care breaks down because prevailing practice is deficient, would it not make more sense to judge the quality of building design and construction on the basis of more general legal principles such as merchantability, implied warranty, and so forth? It seems that these questions are susceptible to creative legal thinking and legal strategy. Another factor that requires pioneering in this territory is I apologize for fumbling. Another factor that requires pioneering in this area is incomplete guidance from learned treatises. Now, learned treatises are books and articles that can be cited as authorities. For example, the ASHRAE Handbook, which is a series of 4 volumes that you see here in the picture, the smaller, slender volumes. A new one comes out each year in succession. This is the best known and most widely used by engineers involved in building energy systems, and it's pretty good. It also should be the leading resource for architects because it deals with the loads on the building, the heat and cooling loads, although most architects probably have never seen it. And there are other related handbooks and textbooks. For litigation, the attorney wants learned treatises that are comprehensive, that are objective, and that provide a balanced view of the issues. But unfortunately, there are few learned treatises related to building construction that meet all 3 of these criteria, especially the last one about providing a balanced view of the issues, which would indicate the best practices that should be followed. And that's one reason why I wrote the Energy Efficiency Manual for the commercial and industrial sector, and Superhouse for the residential sector, where we explicitly state the best methods to be used. Codes and standards are going to be a major litigation issue if the damages involve design or construction practices, so the attorney should be prepared to deal with them. Now, there are codes and there are standards. Both are important, but they're not the same. A code, such as the National Electric Code, is a legal requirement within the jurisdiction in which it has been enacted. And I'll mention that the National Electric Code is basically enacted everywhere in the United States. A standard, such as the ASHRAE 55 comfort standard, is an expression of the collective wisdom of specialists, indicating the state of knowledge at the time. A standard may or may not be suitable for reference in a code. For example, the ASHRAE 55 comfort standard, I think, is too preliminary and too vague to be used as a code, whereas ASHRAE standard 90 is the basis of the underlying basis of most energy efficiency codes. So it depends on the standard as to its legal status. In litigation, there will be argument about what the building designer was required to do by law and what the designer should have done based on knowledge that was available at the time. The codes and standards that existed at the time the facility was designed, or it was built, or it was modified, help greatly to answer those questions. Now, these are the various kinds of codes and standards that are relevant to litigation in buildings damages. The first building codes were created to ensure the physical safety of occupants, primarily from fire and structural collapse, and those came into being around the beginning of the 20th century, the end of the end of the 1800s. Such safety codes are now highly evolved, and they're very effective within the range of issues they cover. As we notice, buildings in the United States don't fall down, and as we notice, they rarely are consumed by fire. The International Building Code is currently the most prominent of these codes. It takes over from earlier codes such as the SBCC and so forth, and it is widely adopted. And among other things, it incorporates the venerable National Electric Code. Code coverage of health came in much later, and it's limited, primarily consisting of ventilation standards. There's little or no code guidance for the direct prevention of mold, pathogens, or allergens. There is some code coverage to prevent proliferation of pathogens in water heating systems. The primary standard for comfort is ASHRAE Standard 55, which deals primarily with thermal comfort. And as far as I know, there are no effective codes for other habitability issues, such as protection from glare. Equipment efficiency standards really took off starting in the 1980s, and by now they have been enacted for a majority of energy-using equipment and appliances that are used in buildings. They have proven to be very effective because they are narrowly definable, they are testable, and they are enforced on a captive audience, who are the equipment manufacturers. But because efficiency ratings have commercial and competitive value, there's a certain amount of gaming of the ratings by manufacturers. And finally, codes and standards for energy-efficient design are chaotic. It is difficult, in my opinion, and perhaps impossible, to prescribe how to maximize energy efficiency in a building generically. The correct approach is for the designer to optimize each aspect of the design, considering all the factors that are involved in each aspect as he comes to it. Now, in groping toward a way to prescribe the energy efficiency of buildings, various kinds of guidance have been put forth by various sponsors. And what we have are, first of all, prescriptive standards, which attempt to tell the designer item by item in the building how the building should be designed. And the initial and still largely dominant prescriptive standard is ASHRAE Standard 90. And it is broken into three main parts. The first part deals with the building envelope, which is imposed on architects primarily. The second part is about the HVAC, and the third part is about lighting. It isn't quite cut that clearly I have been on the Standard 90 committee and have fought losing battles to try to make the thing a bit more coherent, but that is the lead prescriptive standard at the present time. Then you have what are called performance standards, which are almost the opposite of prescriptive standards, in which, in the extreme case, nothing is specified except that the building must meet a target of some amount of energy consumption expressed in typically BTUs per square foot per year. The most famous of those was the Building Energy Performance Standards, which the architect profession created in the late 1970s, primarily in opposition to ASHRAE Standard 90, and it faded away, I think, by about the mid-1980s. Appendix G of Standard 90 does offer a performance-based approach as an alternative to the primary prescriptive approach of Standard 90. I myself don't see the logic in that, but I've been outvoted. Then we have relative rating systems, of which the most prominent at the present time is the Energy Star building rating. And basically, in order to get Energy Star rating for your building, it has to be in the top 25% of efficiency of buildings for which there are data. But since energy efficiency in general is very poor among buildings these days, what the Energy Star rating does is to say that your building is the best of a bad lot. And then we have green rating systems, of which by far the most prominent is the LEED rating system, and LEED stands for Leadership in Energy and Environmental Design. It is a point scoring system in which you get points for doing different things that the sponsoring agency considers commendable. For example, you get points for putting electric vehicle charging stations in front of your building completely without regard to whether anyone actually has electric vehicles. You get points for having locally sourced building materials. So if you're on the East Coast of the United States, you get all the points because most of the building materials are made on the East Coast of the United States. Whereas if you're in Alaska or Hawaii, you get no points. That makes no sense to me. And indeed, a lot of people don't think much of the LEED rating system, and studies are showing that LEED-rated buildings seem to be no better than any other buildings. And finally, enforcement is spotty, and it may be irrational, particularly for energy efficiency codes. We've done studies that show that in wide swaths of the United States, there's no enforcement of energy efficiency whatsoever, whereas in other places like, for example, California or Montgomery County, Maryland, you have very intensive enforcement of efficiency codes. So those will be major litigation areas. And then the next issue that we're going to deal with is how difficult is proof. Of course, the ultimate litigation challenge is proving your case. So how difficult, one of the questions to be asked, particularly by the client who has to undergo the expense of the litigation, is what's his probability of winning the case? From the standpoint of the technical expert, we can put cases into three categories. First, cases that are easy. There's probably never a slam dunk in litigation, but prevailing becomes likely if the expert can show that something violated the laws of physics, or he can show that damages are demonstrably caused by equipment that is demonstrably defective. Then there are cases that are intensive. In particular, to determine the cause of excessive energy costs, the expert must go step by step through the design and then exhaustively examine the physical condition of the building to tease apart all the causes. This requires considerable work and expense, but the truth will come out if you have the right expert. And then there are cases that are inherently difficult. The theory may be debatable, or physical evidence may be hard to produce. These are like the early cases involving tobacco and asbestos or the dangerous side effects of some drugs. A current example is geothermal heat pumps. These are expensive systems that just don't seem to be working as promised, and a number of experts think they understand why they can't perform well. However, proving the case may require data that would take several years and expensive instrumentation to accumulate. And also, you're going to be arguing against a strongly established industry segment that knows enough about its weaknesses to have strong defenses ready at hand. So, that completes our discussion of litigation challenges, and our last topic is how to select your experts. In this emerging field of litigation, attorneys will need effective experts, so how do you find them? Here's where to start. Major expert agencies offer broad coverage. TASA is the major agency for experts, and that's why TASA is hosting this webinar. They can put you in contact with experts who have a wealth of expertise in many different areas. Forensic engineering firms can be good for more narrowly focused cases. They may specialize in structural failure or causes of fire or other individual areas. Typically, though, they would not cover the kinds of damages, especially the breadth of damages that we have seen or have been discussing in buildings. But I think TASA will be quick to point out that such specialists are on the TASA roster also. Seek experts who wrote the book on the subject. Published writings reveal the author's competence, objectivity, and ability to clarify issues. And those are the three things you want in an expert: competence, objectivity, and the ability to make the case. But beware of advocacy journalism by people who are experts or claim to be experts. For example, I get a stack of magazines each month, one of which is related to plumbing engineering. It has a monthly column about solar energy, which is written by a man who works for a solar energy company. This author promotes the installation of solar energy, even in places where it doesn't seem to make sense. You don't want someone like that who has a glaring lack of objectivity on your side of the case. Better he should be an expert for the other side of the case. Seek experts who teach other professionals. Teaching well is part of testifying well. And some cases require multiple experts. Select one expert to lead the technical case. Your experts need to be an effective team, and the team needs a coach to keep everyone contributing in a complementary way. Otherwise, your experts may end up working at cross purposes, undermining each other, and leaving gaps in the case. Finally, to summarize, a vast amount of building-related damages are not being redressed, as we have said, and it's your business as the attorney to change that. The client's initial complaint may be the tip of an iceberg. Identify and evaluate all the damages that have actually occurred. When a client brings you a complaint, consider it to be a symptom, not a diagnosis. Discover what the actual damages are and the actual causes. Select your litigation allies and opponents carefully, as we discussed before, or you may shoot yourself in the foot. The case may benefit from resourceful legal thinking. As we've said, this area of litigation is still evolving. It is not a cookie-cutter or fill-in-the-blanks area of law. You are pioneering. The case may take special care in selecting your experts. In this area of damages, your experts will need both depth and breadth, along with the ability to sort out a variety of issues. Create clarity in the mind of the tribunal. Bring out the facts, the damages, and the responsibility in bold relief. Avoid the trap that I have seen of allowing the judge or jury to be confused with a flurry of technical charges and countercharges. The subject area is highly technical, true enough, but the argument should not be. And finally, prepare. We all like to think back on our good experiences in litigation, and we cringe to recall the bad ones. Fortunately, most of my experience as an expert has been in working with good attorneys, but a small number of less satisfactory experiences, all related to inadequate preparation prior to deposition and trial. The attorney should prepare his experts as thoroughly as he prepares himself. It's been a great pleasure to be with you today, and I thank you for the time you've invested in participating. I hope that the ideas we have explored in this pair of webinars will repay your time, hopefully handsomely. And covering a new area of litigation that is so large and complex in 2 short sessions may seem like drinking from a fire hose. But you can review this presentation at your leisure by downloading both segments from the TASA website, and you will soon see how it all hangs together. So now I look forward to this final opportunity to hear your comments and questions.
Thanks, Don. If all the attendees could type in the passcode right now, that'd be great. Our first question is, are there any recent developments in glass, such as long-lasting films, either applied or sandwiched, that affect heat, cooling, and UV issues?
Oh yes, there are. And in fact, and there have been for years. There's a fellow named Steve Selkowitz out at one of the national laboratories in California who spent his entire career on that issue. And the problems of glass as being a major energy waster are so well known that everyone has been trying to solve them. But so far, the solution hasn't been found. There are a couple of problems with glass. One is its very poor insulation value, and the only way that you've been able to make much of an improvement on that is by increasing the number of panes of glass. But beyond about 2 sheets of glass, the window gets very heavy. People have also been trying for a good number of years to have a double pane window that has vacuum between it. Vacuum, of course, is an absence of any material, so you have no thermal conduction across a vacuum. The trouble is no one has yet figured out a way to make a vacuum-filled window that doesn't crack at the edges. Then the other problem with windows is the cooling load that occurs by virtue of sunlight coming in. And the fundamental problem here is you want the window for view. The building has no business having windows unless they give you a useful view of the outside. Now, sunlight, outdoor sunlight, is about 100 times brighter than you will be comfortable with reading black ink on white paper. So the darkest window that you have in a building reduces the amount of incoming sunlight by a factor of 10, roughly. And a window that's that dark or that reflective looks really strange and not very attractive. But even so, it's still 10 times, admitting 10 times too much sunlight into the building. So at the present time, there's only one right way to design glazing in a building, and that is to shade it from direct sunlight at any time that the building requires air conditioning. But people keep looking, and that is a very active area.
What are the unresolved areas of law relating to these types of building defects?
Well, the one that stands out for me is standard of care, and we talked about that. We don't have enough precedent to say that standard of care will or will not get a designer off the hook if his building is no worse than a bunch of other buildings and they're all bad. So that's the principal one that I, as a non-lawyer, can think of.
What is the legal status of energy efficiency codes and standards?
Every design professional is governed entirely by every code and standard that exists. And there are energy codes and standards that govern in every part of the United States. So if a designer of any kind, architect, engineer, civil engineer, is not following those standards, he is in violation of law.
What do you think about the LEED rating system?
I don't think that it should have any legal weight, although it may do so because it's currently very fashionable. And as I described, LEED is a point-scoring system that's highly arbitrary, and some of its requirements aren't strongly defensible, which is a nice way of saying they don't make much sense. And as I said, emerging studies seem to be indicating that LEED-rated buildings are not significantly better than other buildings, and some studies are showing that some LEED-rated buildings are actually much worse than average. So I would not use the LEED rating system as any kind of a guide in design.
Can a consulting engineer escape liability by asserting that his design decisions were altered or overruled by an architect who heads the design team?
I don't think so, because each individual licensed professional, particularly a licensed professional, and the mechanical engineer is licensed, has complete authority and autonomy within his own field. So if a mechanical engineer designs a deficient HVAC system and then says, oh, well, I did that because the architect wasn't willing to pay me enough to design a good system, I don't think that gets him off the hook at all. I think the law and the licensing agency for professional engineers ought to throw the book at him.
Okay, and our last question, what books have you written?
I have written two. One is the Energy Efficiency Manual, and you saw a little picture of that in one of the slides on top of the stack. That one came out in the year 2000. It is for the commercial and industrial sectors, and its main theme, as the title implies, is energy efficiency. The second book I wrote is called Superhouse. It came out last year. It's still winning awards, and look it up on Amazon.com. The name is Superhouse, 2 words. It's all 5-star reviews except for 1 or 2. And that was written more broadly to allow anyone of any background to design an ideal home for himself. Energy is a very main theme in there, but it's only one of all the themes that you ought to be looking at in designing a home. So I brag on that one.
Okay, that was our last question. Don, thank you so much for presenting this 2-parter for us. It was very informative. In addition to being your best source for testifying and consulting experts for the past 60 years, TASA also offers e-discovery and forensic solutions, free interactive webinars, cybersecurity services, Dana Life videos, in addition to research reports on expert witnesses, such as the Challenge History Report 2.0, Preliminary Screening Report, and the Expert Profile 360. I want to take this opportunity to thank everyone for attending, and most especially Don Wulfinghoff for his time and effort in creating these presentations. If you would like to speak with Don, or if you would like to speak with a TASA representative regarding an expert witness for a case that you are working on, please contact TASA at 1-800-523-2319. Deb Morris, one of my colleagues, a regional manager, has been sitting in on the webinar and will contact you to follow up on the webinar. Thanks again for attending, and this concludes our program.